We'll achieve our goals through partnership, creating opportunity. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a stand for our visions of hope, making future plans for the people to grow in a life filled with happiness and glee. Hear us sing, building the future is our legacy. It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health, and technology. We will share our expertise by promoting knowledge and policy. It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health, and technology. achieve our goals through partnership, creating opportunities by working hand in hand together. Accomplish all our dreams for a better quality of life is now within our reach. Let us take a step for our precious goals, making future plans for the day about to grow in a life filled with happiness and play. Here at SEAMEO, living the future is our legacy. start to make a difference, teaching everyone to learn. Through science, health, and technology, we will share our expertise. By promoting knowledge and policies, we can build a better world. Let us take a step for a precious world, making future best for the people to grow in a life filled with happiness and faith. Give us SEAMEO, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a step for a precious soul, making future best for the people to grow in a life filled with happiness and faith. Give us SEAMEO, building the future is our legacy. It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn. Through science, health, and technology, we will share our expertise. By promoting knowledge and policies, we can build a better world. Let us take a step for a precious soul, making future best for the people to grow in a life filled with happiness and faith. Give us SEAMEO, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities. By working hand in hand, we can accomplish all our dreams. For a better quality of life is now within our reach. Let us take a step for a precious soul, making future best for the people to grow in a life filled with happiness. to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health, and technology. We will share our expertise by promoting knowledge and policies. We can build a better world. Let us take a step for a vicious world, bringing future us for the people to grow in a life filled with happiness and faith. Give us SEAMEO, building the future is our legacy. We'll achieve our goals through partnership, creating opportunities by working hand in hand together. Accomplish all our dreams for a better quality of life is more within our reach. Let us take a step for a vicious world, making future us for the people to grow in a life filled with happiness and faith. Give us SEAMEO, building the future is our legacy. It's time to open our eyes to a bright and promising future. We'll rise to the call of the times and create a stronger tomorrow. Let's start to make a difference, teaching everyone to learn through science, health, and technology. We will share our expertise by promoting knowledge and policies. We can build a better world.
Good morning to all the participants. I'm sorry, good afternoon to all the participants. Welcome to the SEAMEO RECSAM Discourse in Science and Mathematics Education. Today we're going to talk about SEA-BES project and STEM education by Mr. Domino Nador Dizon Mangau. Before we start, let introduce Dr. Dom. Mr. Dom. Okay, Mr. Dom presently works as a education specialist in science education at the R&D of the Southeast Asian Minister of Education Organization Regional Center for Education and Science and Mathematics, SEAMEO RECSAM in Penang, Malaysia. Mr. Dom served for a total of 12 years in SEAMEO RECSAM, 5 years in training program divisions, and another 5 years in R&D. At RECSAM, Mr. Dom is actively involved in conducting research, publication, regular training courses, in-country courses, workshop, and developing instructional materials. Mr. Dom also attended numerous specialized training and published a number of books, publication, and conference papers. Presently, he's the coordinator of the SEA-BES, Southeast Asia Basic Education Standard, which published the Common Core Regional Learning Standard in Science and Mathematics. Without further ado, I'll present to you Mr. Dom.
Thank you very much, Mr. Sharfuddin, for a very generous introduction and for moderating this afternoon's online discussion. Okay, a very good afternoon, everyone. Welcome and thank you for your attendance this afternoon. Officially, on behalf of RECSA management and staff, headed by the Center Director, Dr. Shah Jahan bin Azan Arkuti, our 3 Deputy Directors, Mr. Amran Mahadi for Administration, Dr. Mariam Othman for Research and Development, and Dr. Wan Noor Azmin for Training Program. My dear colleagues, senior specialists, managers, unit heads, and staff, we sincerely appreciate and thank you for your participation on this online discussion entitled Discourse in Science and Mathematics Education, SEA-BES Project and STEM Education. Can we share my PowerPoint? I modified a bit of my sharing as SEA-BES and STEM related initiatives. I have been coordinating in RECSAM for the past 6 years. I'm very thankful for RECSAM that I have stayed this long serving the center, and I'm grateful for all the opportunities it has afforded me. As Mr. Sharfuddin has shared, I had served 7 years in the training program and almost 5 years in the research and development division. So, welcome everyone, and please write down your questions about my presentation and feel free to ask them later towards the end of my presentation, and I will be glad to answer them. So basically, I would like to share to you the 4 projects which are subdivided into completed and ongoing projects. So two are completed ones and two ongoing ones. I do hope that you will learn something from these research projects and publications, and hopefully we can work together in some future undertakings of exam on these, especially in the ongoing projects. So let me start on the first project, which is the Common Core Regional Learning Standards. So the basic reference of this is the SEAMEO agenda, particularly priority area number 7 on adopting a 21st century curriculum. SEAMEO Secretariat, based in Bangkok, is giving all the 27 SEAMEO centers some guidelines on policy directions where the SEAMEO centers could pursue. So these 7 priority areas include early childhood care and education, addressing barriers to inclusion, ensuring resiliency in the face of emergencies, promoting technical and vocational education and training, revitalizing teacher education, promoting harmonization in higher education and research, and adopting a 21st century curriculum. So the SEA-BES project is falling under priority area 7, adopting a 21st century curriculum. Yeah. So you see the book is the output of this SEA-BES project, which is a regional curriculum, the aim of which is to produce a learning standards comprising of grades 1 to 9, one for mathematics and one for science. And of course, the aim is uh, to provide the world-class learning standards in these two subject areas as the specialized field of SEAMEO RECSAM, Science and Mathematics Regional Center. So, to give you the aims of the maths standards, develop mathematical values, attitudes, and habits of mind for human character, develop mathematical thinking and processes, acquire proficiency in mathematics content, and apply mathematics in appropriate situations. For the aims of science, we have personal development through acquisition of scientific knowledge, personal mental development through the use of scientific skills and processes, development of individual attributes, attitudes, and perceptions, and development of values and skills as a responsible member of society. Yeah. So, uh, this Common Core Regional Learning Standards is available at RECSAM website. So just visit this URL and you can access and download these learning standards. Now I will share to you the second project. It's about attitudes and beliefs towards science and science education of year 9 and 10 Southeast Asian students, a survey research. Basically, it's an online survey. So this is in collaboration with the Faculty of Education of the University of Technology, Sydney, Australia, under Dr. Wan Ung and Dr. Jennifer Vergoodson. So the respondents of this study are the 7 ministries of education of SEAMEO. And the status of this project, the publication is now in camera ready and ready for printing and dissemination to the 11 MOEs. So once it is done, the PDF copy will be shared to all the MOEs and to the public as well via RegSam website. So, of course, this research would not have been possible without the cooperation of country research coordinators. So, 7 countries here: Mr. Kelvin, lady from Brunei Darussalam, Miss Rose Kartini binti Haji Abdul Rahim from EPRD MOE Malaysia, Mr. Joseph Gutierrez from MOE Philippines, Dr. Nguyen Zuan San from MOE Vietnam, Dr. Maria and Dr. Lambas from MOE Indonesia, Dr. Kiao Zanla from Yangon University of Education, Myanmar, Mr. Ekasit Piasang Tong from the Ministry of Education, Thailand. So this study involved a total of 5,375 student respondents by gender, boys and girls, and classified also as grade 9 and 10. The study looked into 7 categories or variables, which are what students think about science, science outside school, teaching and learning science, self-efficacy in science, how scientists work, interest in science topics, future participation in science, and future participation in science rather. So these are the 7 areas which we looked into. So this was through a survey questionnaire, a 4 Likert scale. Strongly agree, disagree, and strongly disagree. The questionnaire was translated into the language of the choice by each MOE, and then the data was analyzed through SPSS. Statistics include mean, standard deviation, the reliability by Cronbach's alpha. T-test was used to measure significant differences between genders and year level. And for the effect size, we use Cohen's D. So basically, this is a descriptive cross-sectional study. Now, looking at the summary on the 7 categories by country, no, the red marks are highlighted there, comparing the country means or average against the regional mean average. So, among the 7 categories, what students think about science basically means relevance of science and technology to the lives of the students. So, 3.24 is the general average or mean average, which is the highest, and the lowest is the self-efficacy in science, which obtained only 2.52, which is slightly positive and neutral, no? Given that 2.5 scale, no? As positive. So I know we have a lot of Malaysian educators who are quite interested in the results. So, looking at Malaysia, you see only one category, which is how scientists work, fall below the average mean, which is 2.47 against 252. So generally, the grade 9 and 10 Malaysian students have positive science attitudes. Okay, So maybe you are interested on the details of each of the contents of or the items in the questionnaire. So for the first category on what students think about science, no, it is interesting to find out that 98% of the students reported they enjoy acquiring science. New knowledge about science, 96% they are interested learning about science, and 97% values science and technology as creating impact, no, as a powerful force in uh, impacting society and living standards. So, with regards science outside school, 86% of the respondents agree that they love or like visiting science centers and museums. 84% use social media to access information. 78% likes to attend science activities outdoor, like science clubs. 78% also watch science TV programs, and 73% of the respondents like to read magazines, books, about science. For teaching and learning science, it's quite interesting to have a contrasting results between an inquiry um, oriented science teaching against teacher centered, because students, or 92% of them said they are given opportunities to explain science ideas. 89% of them says um, they are given opportunities to do research online, and 83% of them reported they spend time doing experiments in the laboratory. However, in contrast, 93% of them are saying that they follow instructions of the teacher. 92% of them says the teacher is explaining the lesson to them. 86% reported that the teachers tell stories about the lives of scientists and their discoveries, and 81% of them reported that they learn mostly from textbooks and lectures. So I think this is a very good data for us teachers, no, to really move towards an inquiry based, no, and student centered approach, no, rather than on a traditional, no, teacher centered approach. Now, for the self efficacy there, no, which has the lowest mean, um, students find science difficult. 61% of them reported that science is difficult, but also 61% reported that they learn science quickly. 59% like science better than most other subjects. And only 22% of the students find science boring. So even though this is 22%, still we would wish that now we would reduce this number, that all our students would not find science a boring subject, but a very engaging and no, exciting subject. For science is a world of no, discovery. Okay. The next category is interest in science subjects. So for interest in science subjects, 91% of the students are interested in ways how science experiments are designed, and also how scientific data are explained. We looked into also the four popular science topics among the student respondents, and it came out that human biology, endangered species, biology of plants, and climate change came out as the four most popular science topics. Looking at the four least attractive topics, were as follows: science versus religion, nanotechnology, geology, and topics in physics. These are the four topics where our students were least attracted to. However, in some countries, nanotechnology, for example, um, was rated very high. And it simply shows that our students now are challenged to explore advanced topics now, even though they are just in the high school level. And finally, in the future participation in science, 92% of the students agree that they like to study more science in the future. 85% agree that they like to study science at the university, and 76% of them like to work in a career involving science. So those are the significant highlights of each of the specific items in each of the seven categories. So now, in summary, by gender, the girls out of the five categories were slightly higher only in two as compared to the boys, which are in science outside school, 3.08 against 3.05 in the boys, teaching and learning science 3.18 against 3.08 in the boys. However, so the boys, on the other hand, have higher average in five categories as compared to the girls. The regional mean average, girls 301.01 and boys 3.04. So it's still insignificant, very small difference. For the year levels, in the slides, we can see year 9 3.0 and year 10 3.01. However, it's very interesting that out of the five categories, year 9 registered uh, has registered four categories higher than year 10. So the year 9 students are higher in teaching and learning science 3.12 against 3.10, self-efficacy 2.54 against 2.47, how scientists work 3.01 against 2.93, and interest in science topics 3.08 against 3.01 over year 10. So we can see here that um, there is a, a reduction in terms of interest in science among students, that they are they have positive or interest in a lower year level based on the individual categories as against the mean in higher level. So this is a challenge to us educators, how to sustain, how to maintain the interest of students in studying or learning science. Okay, in conclusion, so the mean is above 2.5 in all seven categories. Though there are differences in gender and year levels, the effect sizes were small and also were not significant, consistent with TIMSS and PISA results. Okay, an inquiry-based approach and student-centered uh, positive influence on attitudes. Okay, now let's move to the next project on STEM. So I know very well that MOE Malaysia is aggressively promoting STEM education, and now we know very well that it is very significant because of these forces, IR 4.0, digital disruption, Internet of Things, job landscape, and skills outlook. Yeah, for STEM education goal according to the MOE Malaysia, so producing STEM literate citizenry. How? Through these means, using technology, designing, inventing new products, creating new ideas, logical thinking, solving problems creatively and innovatively. So these are the skills or literacies included in STEM. Now, how did Rexam address this? So in CCRLS in mathematics, we address the STEM education through the mathematical thinking and processes, okay, which have emphasis on problem solving and application in the daily life, as well as innovation in society. For the CCRLS in science, we have an inquiry strand and a specific topic on the world of STEM and the subtopic how STEM works. So in detail, we have specific indicators in the three key stage levels. Key stage grades 1 to 3, grades 4 to 6, in progression, in depth and in breadth of, and key stages grades 7 to 9. So the next project is on STEM is teaching to transform 21st century skills and design thinking in STEM context. This is our third project. This is an ongoing project in collaboration with the Faculty of Education, Monash University. This involves 11 ministries of education of SEAMEO, SEAMEO Secretariat, and SEAMEO Sister Centers. So the outcome of this project is the RECSAM's planning and design learning model or paddle framework or model. So this model is comprised of two, the planning model for teachers and this design learning process for students. So for the planning model, I will discuss in detail each of the contents. So, showing to you now are the participants, Malaysian educators with the Monash team, training team who came in November 2018 for this STEM workshop. Yeah, so the participants were exposed to different STEM challenge activities to draw out the model. Of course, these participants reflected on the processes of how they solve the challenge or the task given to them. Okay, so this is the draft output, which will be finalized through a regional workshop uh, next year. So the planning process for teachers, as you see in the slides, so the first stage there is creating enthusiasm. Then planning for teaching, design learning process for students, and reflection. So this is still a draft and will be open for finalization, inputs among the MOE experts who will be joining the regional workshop together with Malaysian educators. So this is the draft design learning process for students. So we have there on the sides, every great design begins with a great dream or a great problem. Designing is so easy. That's why it is so hard. Prototyping is a way you talk to your ideas. If the plan doesn't work, change the plan but never the goal. So you see, it corresponds to the four stages: emphasizing, developing design ideas, prototyping or modeling, and proposing solutions. Yeah, so the world today is being challenged that, uh, I mean, specifically the science and mathematics education, that teachers rarely integrate human characters and values. That's why, if you notice, emphasizing, is emphasized in our model. Human values, human character is very important, um, above all things. So we should believe that the facts and nature are very related to the development of values of the children. Okay, so the challenge now is because studies show that science and math teachers have that perception that uh, values are more of cognitive dimensions and rarely seen integrated with affective dimension. So they see science and maths as value free, and that, of course, mathematics is seen as cold hard facts figures. However, many authors would challenge this, that science and maths are not value free, but they are value rich, or value laden subjects, because we emphasize reliability, accuracy, precision, general simplicity. So, in science education, we have to remind ourselves, the most important is process and context of science and or maths, but not merely content. So we need to give opportunity for students to engage in scientific activities. Okay, they have to find proof or evidence to justify their arguments. So character education is very important to cultivate in our students. That's why in the quote here of Abigail Adams and Ralph Waldo Emerson, great learning and superior abilities will be of little value and small estimation unless virtue, honor, truth, and integrity are added to them. According to Ralph Waldo Emerson, the purpose of life is not to be happy. It is to be useful, to be honorable, to be compassionate, and to have it make some difference that you have lived and lived well. So that's why there is a need for character education or emphasis in values development in science and mathematics. So respect, responsibility, honesty, fairness, and compassion. Going back to the CCRLS in mathematics, so forgive me, it's so small, but we are highlighting here the mathematical values, attitudes, and habits for human character. In science, we have values and a long list of values and attitudes to be developed. Now, so going back to the design learning process now for students, now, emphasizing empathy as the most important first stage in the model. Yeah. So when we say empathy, it's the ability to share someone's feelings, experiences by imagining what it would be like to be in that person's situation, being sensitive, being aware, and understand the feelings and thoughts of others. Okay, so uh, students can see the impact of STEM in their lives and the lives of others. So making STEM content relevant, and that students would see that it is a once the students can come up with a solution, so they are contributing to the community by providing solutions to relevant social problems or social issues. And if they take more of a interpersonal and empathy based approach, so we can say they truly can say they are a STEM person. Yes. So we should not look at science, mathematics, and technology as a separate subject, no, but interdisciplinary, multidisciplinary, no? And whatever subject we have, we make it culturally relevant in the lives of our students, no, and there's a focus, social issues, for example. For example, because of the COVID-19 pandemic, no, the use of face mask no, is very relatable no, to the life experience of students. So we might can give a challenge or a task for the students to design a tool to collect discarded face masks. um, Because now collecting this by hand is unsanitary because it might contaminate the students now with the virus. So this is very interesting for them to create some tool to collect discarded face masks. So the four stages of the design learning model can be used. So empathy, development of the design, creating or the model or prototypes, and finally proposing the final solution. So empathy would be the analysis of the real problem. Uh, then STEM thinking, higher order thinking skills, knowledge, and valuing would come in. The building, testing, and improving of the prototypes. So trial, then improve, modifications, and finally presentation, and communicating the final results. So they can make use of this collaborative reflection activity. What is the problem about? What's the problem asking them to do? What are the main considerations in their design? What knowledge or content do they need, no, to solve the problem of designing a mask collector, no, or a tool or instrument? So maybe the students now with the internet can look or Google into existing tool, no, to collect some things, uh, and then modify the existing gadget. So maybe some designs that uh, students could come up are these samples. The creativity of our students are limitless, so they could imagine things we adults could not imagine. Uh, Coupled by their skills in technology, modeling, application of mathematics, calculations, and so they can come up now with a very good model or prototype. Yeah, so they can reflect on their learning afterwards. So, like for this first box there, what is something that made you think? And for their affective dimension, how do you feel about the information presented? Is there something you disagree with? What are you taking away? So many things can come up now when students work collaboratively and communicate with each other. How they would go on with solving the challenge or the task. So experience alone does not lead to learning. Reflection on experience is essential. So that's why we teachers should not just be contented with mere output, no, or product, but we have to really delve deeper, no, on the process the students went through in coming up, with some concrete solutions on the tasks that they are given. So we need to relook at STEM education from a focus on a disciplined based science, technology, engineering, mathematics to a more of transdisciplinating. No, so it's progressive. It's action. No, it's behavior. Uh, from learning, which is just acquisition, to participating. So students have to communicate and convey and participate in discussions, in the solution of the tasks or problems. Uh, Science should not be looked at as a method, but an inquiry, inquiring, looking into different areas, that there is no one method, that could solve a given problem, or one method or solution. So it keeps on evolving, different strategies that they can employ. Technology is just not merely usage, but have to go through designing, go beyond usage. And for the engineering aspect, we have to look at it as innovating, no, beyond application, or repeating what has been um, constructed or designed or produced, no, or developed, or inventions invented, but continue in innovating. Mathematics should not be looked as mere calculations, but extending into modeling. And finally, STEM education, not just reception, looking at it being receptive, but as a contributing factor. No? It's progressing, contributing to solutions finding. Yeah, so this is the last project, the guidebook, which is an ongoing project. Um, if you notice, if you can recall, I presented the book, which is the first output uh, in 2017. So we are moving towards how to translate this into teaching and learning practices. What are the fundamental knowledge that students have to learn across three key stages as expressed in these learning standards. So the guidebook, based on the survey from the Ministries of Education, the SEAMEO, we will be developing content standards in the four strands: life and the living world, which is equivalent to biology; material world, equivalent to chemistry; energy and change. Oh, this is physics; earth and space, as it is. So we had the first workshop last 5th and 6th of August with the science experts from Malaysian universities and teacher training institutes, as well as master teachers, no, in Penang and neighboring states, Kelantan, for example. Another content of the guidebook would be the cross-cutting concepts and examples. So again, in progression, into three key stages. So those who are familiar with the new generation science standards of the US, so we base it somehow, the cross-cutting concept from there, which includes patterns, cause and effect, scale, proportion and quantity, systems and system model, energy and matter, structure and function, stability and change. So somehow we teachers, we are preoccupied with delivering the mastery of the content, and forgetting, no, the relationship among concepts, no, within, no, the topic, within the discipline, and among the disciplines. So it's good that we will include this so that teachers, no, are guided, reminded that they have to relate each, concept whenever they teach a certain topic. So we had this workshop the 12th, 13th of October. Another content of the guidebook would be science inquiry and engineering design practices. So again, the reference of this is the new generation science standards, but we merged it with our existing science inquiry strand in the CCRLS in science. So these are the 8 practices: asking questions and defining problems, developing and using models, planning and carrying out investigations, analyzing and interpreting data, using mathematics and computational thinking, constructing explanations and designing solutions, engaging in argument from evidence, and obtaining, evaluating, and communicating information. So these are all draft outputs, and it's ongoing, and we need a series of workshops more to finally refine and finalize these with the experts now from the 11 MOEs and science experts from Malaysian universities and science centers and SEAMEO sister centers. So, and the remaining chapters of the book would be country reports on inquiry-based science with an inquiry lesson exemplar and country reports on STEM education with a sample STEM lesson. So we will choose a model inquiry and STEM lesson from the 11 countries. If ever they can provide a good sample, then we will append it in the book publication. So I think those are the four projects under SEA-BES in relation to STEM education. So thank you very much, everyone, for your patience and in listening to my presentation. So I welcome questions. It should be. Do you have?
Thank you, Mr. Dom. Now is the question and answer questions.
Yeah. So we can go back to the first slide. No, no. We can go back to the four.
For the time being, I would like to ask all the participants to switch on their video. We're going to take a screenshot. Uh, Still waiting for the others to switch on their stop. Can you switch on your video? So, we're still waiting for another 10 participants to switch on the video. Is it? That's good. That's all. Can we take the pictures now? Most of them are here. Okay, we're going to take the pictures. Majority are here. Okay, we're going to take it on 3. 1, 2, 3. Oh, you don't have the camera. Oh. Is it? Close the session. Okay, now I would like to say thank you to all the participants, and I would like to, on behalf of the RECSAM, I would like to say thank you for Mr. Dom for giving us this opportunity, and I would like to wish Mr. Dom best of luck. Maybe this is his last webinar with us, and for that, thank you. End session.
Okay.